Good evening to Dr. Olawale. My name is Muhammad Afnan bin Syarul Azman and we are from BMMV section 1-2. So today we are going to present our project assignment for torsional loading evaluation from actual structure, which is stand mixer. For the first part, I will present about idealized model. For idealized model, the torsion can be defined as the twisting or wrenching of a body by exertion forces, tending to turn one end or part about a longitudinal axis, while the other is held faster or turned in the opposite direction. The mixer beater is used to rotate a set of beaters in a bowl that containing food to be prepared by mixing it. It is connected to the end of shaft, which when there is torque applied on the mixer beater, it will rotate and creates a torsional force on it. For the next part, for the assumption value, I will pass to Muhammad Hafiz.
Thank you, Muhammad Afnan. So we assume this mixer beater is made from stainless steel. The mass of this beater is 0.68 kg. Based on material stainless steel, we get the modulus of rigidity is equals to 77.2 gigapascal. The power is 350 watt. Frequency is equals to 60 hertz. The length of shaft is 0.1 meter. Radius of shaft is 0.01 meter. We assume the factor of safety is 0.99 because we need to calculate the force that will cause the shaft to be broken. So, when the value of safety factor is below 1, it is most likely that this structure will fail. For further explanation on FBD, I will pass this presentation to Muhammad Lokman.
Thank you, Mama Hafiz. I am Muhammad Lukman and I will explain about the free body diagram. This is our study object and we will focus on at the shaft. This is our torsion. Torsion is the twisting of an object due to applied load. This is our angle of twist, which is the angle through which fixed end of the shaft rotate with respect to the free end. The plintery will be our fixed end, whereas the mixer beater will be our fixed end. This is our shear max or the tau max, which is equal to the radius of the shaft, and this is our length of the shaft. That's all for me, and I will pass the next part to the Nazmi.
Okay, thank you Muhammad Lokman. Now I will explain about the calculation. Firstly, we need to find omega by using the formula of 2 pi f, and the value is 376.9911 radians per second. Then we need to find the torque by using the formula of P over omega, which is power divided by omega, and the value is 0.928 Newton meter. After that, we can get the polar moment, which is J, by using the formula pi over 2 times C power of 4. And then we get the value of J, which is 1.5708 times 10 power of negative 8. As we know the value of polar moment, we can find the maximum shear stress by using the formula of TC divided by J. The value of maximum shear stress that we get is 591.0364 kilopascal. Last but not least, the angle of twist that we get is 7.650 times 10 power of negative 5 radians per second by using the formula of torque times length, then divide by shear stress, shear modulus times polar moment. That's all from me. Then I will pass the presentation to Muhammad Zari.
Okay, thank you Nazmi. I will continue the calculation, but before that, I'm sorry if my video is lagging because my line is not very clear right now. Okay, for area, we can calculate the area by using the formula of area for cylinder, which is 2 pi RH. plus 2 pi r squared equals to 6.9115 times 10 power of negative 3 meters squared. Okay, by calculating the area, we can find the allowable force, which is shear stress times the area, and we get the value of 4084.9481 Newton. Okay, for the final part, we need to find the torsional force that will fail the structure. Okay, based on the equation of equilibrium, when the total moment is equals to 0, we can insert the value of negative t plus f times the length equals to 0, and we get the torsional force value is 92.84 Newton. Okay, and then the final one is the force that caused the shaft to be broken, and by using the formula of factor of safety equals to F fail or over F allow, we can find the value for the force fail by calculating the factor of safety times the allowable force. Okay. The factor of safety usually refers to one or two things. So first one is the actual load bearing capacity of the structure or the component. Okay, the second one is the required margin of safety of the structure or component according to the design requirements. Okay, by calculating the factor of safety times the allowable force, 0.99 times 4084.9481, we can find the force that caused the shaft to be broken is 4044.0986 Newton. Okay, thank you. That is all from us. Again, thank you.